phosphate. Calcium phosphate is written as this. Calcium is Ca. It has a valency of 2 plus. The phosphate is an ion or a radical with PO4. That's a phosphate. It has a valency of -3. So if you do not get this work, go back to the page or your account on the ePortal, download something that has senior 1 supplement. You write main those ions. It looks very bad for people who have been at home to come back and still behave the same way, just failing these simple things. If you are here on this platform, make sure you gain from it. Don't just come here for the sake of coming. Okay? So when you are forming this compound, the 3 here, the 3 on the phosphate, we have the power exchange. The 3 on a phosphate, this one, is going to be taken by calcium. We are forming a compound. Then the 2 is going to be taken by the phosphate. This one is going to become calcium 3 PO4. Since they are together, you don't need to separate them. The 2 will just come and add outside the bracket here. This is calcium phosphate. Now, if you're looking for its relative formula mass, RFM, it's going to be calcium, we said is 40. It's going to be 40 times 3. This is 120. Plus P, which is, there is this 2 outside. So we put this 2 here, then open brackets. 2 here, open brackets. Then 4. This P is 31 plus the 4 times this O, which is 16. Then you close your brackets like that. So this 2 is outside, plus 2, open brackets. This one is 64 alone, plus 31. 64 is here, plus 31. It is going to give us, this is a 5, this is 9. It's going to be 95. I don't have a calculator here, but if you multiply 2 times this, you get around you get what? Someone on the calculator, 2 times 95?
190.
190. Add it to 120. What do you get?
310.
310. This is the relative formula mass of this compound. If you fail to come up with the relative formula mass of any given compound, mole concept is going to disturb you to the end. Because what we are dealing with is the relative formula mass of a given substance, then the other bit, which is the moles and the particles you are going to calculate from that value. So make sure you know how to come up with these substances here. There is some whatever we sent on the platform that has senior 1 supplement. So make sure you download it and you write as many compounds as you can. That paper is, I don't know if I can get a copy here. I would have shown you how it looks like. Then you go download it, write many questions as you can. So it looks like this. This is what we have. Here we have things that look like this. Do you see the screen clearly? So here we have valence 1, valence 2, valence 3. So you have seen where calcium falls. It is here. These are positive ions or metals. They are all here. Ammonia, silver, sodium, potassium, lithium as ions. Magnesium, calcium, copper 2, lead, iron 2, and then zinc, aluminium, iron 3. Those are the only ones that have valence 3. In A level, you will add up. Then here we have valency of negative ions in bracket. This is the word radicals. elements that cannot exist alone, but exist in several compounds. An example is hydroxide ion. It has valence 1. A nitrate, nitrite, hydrogen, carbonate, iodide, hydrogen sulfite, hydrogen sulfate, a chloride, a bromide, then this one is a chlorate ion. So valence 2, we have oxide, peroxide, sulfide. Now the difference between an oxide and peroxide is this one has double, 2 up, 2 down. So when it's reacting, this 2 up is the one that moves away. Then the 2 on the low one remains. So this one is the power, is the one you exchange. So a sulfite is here, a sulfate is here, sulfide is there, carbonate. Then we have a phosphate ion and a nitrate ion. Those are the 3 in valence 3. Those are the 2 in valence what? 3. So you have seen why a phosphate ion is. So you write a phosphate PO4. This is series for all of them, including the P and the O together, plus the 4. They have that valency. It reacts with calcium, that has valency 2. There is an exchange of valency. The 3 goes to calcium, the 2 comes to the phosphate. So all of them are there, and then now all gases occur as molecules. They are here. So write as many elements as you can, as you see here, up there. So these are the ones: sodium hydroxide, sodium peroxide, sodium potassium carbonate, magnesium oxide. All these compounds, learn how to write them. Those who can take screenshots, you can do so. Then you write. Because without this knowledge, you cannot write any relative atomic mass of any substance. Like now here, iron 3 chloride. It means that the valence of iron is 3. So if you want to write the one of iron 3 chloride, it's written as this: iron 3, then a chloride. Look for where a chloride is. Which valence does it fall in? A chloride is here. Now, a chloride is here and it has valence 1 up here. You see that? And it's where it is. So a chloride has valence 1, meaning the 3 is going to be taken by what? The chloride. This one is going to take the 1. So the formula becomes iron Fe1. You can't write 1, just leave it like that. Then you put Cl and then the 3. So if you are calculating relative molecular mass of this substance, it is going to be 56 for iron plus the 3 times chlorine, which is 31, after 35.5. All these are there in the table. If you look at our table here, chlorine is somewhere. It's 35.5. It was not included, but in one of these formulas here, we have chlorine somewhere. So chlorine is 35.5. So if you multiply this, that is, multiply this by 3, add it to 56. That is the relative formula mass of that substance. Is it clear?
Yes.
Now, any person who doesn't know to come up with the formula of a compound, because this is at your own benefit. You paid your money so that we can help you. I can't jump from here to the next part before you know how to come up with those things. Because as we talk now, senior tools are free and fair with these things. So feel free. Coming up with the compounds. Can we make them now? Yes? Wendy?
Yes, teacher.
You can come up with a compound now.
Yes.
Okay. Cynthia? Cynthia?
Yes, teacher.
You can come up with a compound.
Yes.
Let's take this question here. I want the relative formula mass of hydrogen peroxide. hydrogen peroxide. Peroxide. Let me show you the paper so that you will not fail to get what I want. Peroxide is there, here. Write it. It is O2, then there's a 2 negative up. Hydrogen, you know where it falls. So I want the formula of hydrogen peroxide and its relative formula mass. That one I'm going to give you a few minutes, about 2. About 2 minutes. Two minutes are done. What is the answer? Yes? Thank you very much.
I've got 34.
Thank you very much. Those who have 34, that's the correct answer.
34.
The one who has
Okay.
18, the one who has 18, you still have problems in writing those equations. If you have 18, you still have problems in equations. Okay. Allow me to continue the next part. Now, this is the first subheading we're having under Molo concept. This is the first subheading we're having under Molo concept. It reads, calculating number of particles. So this is based on the relationship that 1 mole of a substance contains 6.02 times 10 power 23 particles. Now, examples, calculate the number of particles in the following water. In the following, number 1 is water. In water, number of particles in water. We shall say in water, we have only 1 mole. 1 mole of water. This is the one for the molecule. Is equal to 6.02 times 10 power 23 particles. These are particles in the water alone as a molecule. Now, if in the water you have 2 what? You have 2 hydrogen atoms and then 1 oxygen atom. So each of them, we are going to get the number of particles present inside. If they say the number of particles present in the following compound, if they say find the number of molecules present in 1 mole of water, that one is okay. But they want the particles present in the following. In the water, we have 2 hydrogen atoms and then oxygen. We also have to find the number of particles present in 2 hydrogen atoms and oxygen atoms. That's why they say 1 mole of water contains 2 moles of hydrogen atoms. So in the water, we have 2 hydrogen atoms. Then in the water, we also have 1 oxygen atom. So 1 mole of hydrogen atom contains 6.02 times 10 to the power 23
Yo, yo, yo.
times 10 to the power 23 particles. What about 2 of them, because there are 2, isn't it? 2 moles of hydrogen atoms contains what? 6.02 times 10 to the power 23 times what? 2 particles. This one takes us to 1.204 times 10 to the power 24 particles. Then the ones of oxygen are the same because it is only 1. Okay? The ones of oxygen, in water we have 1 mole of oxygen. 1 mole of oxygen. That is equivalent to 6.02 times 10 to the power 23 particles. Those are the number of particles there in water. So if they say 2 moles of oxygen, you first get what the oxygen has, then you look for the other molecules inside the oxygen. What do they have? In oxygen, we have 4 moles of oxygen. This is what they are saying. 1 mole of oxygen molecule contains 6.02 times 10 to the power 23 molecules. But in oxygen, there are 2 moles of oxygen. These 2 here, because they want the number of moles in 2 moles of oxygen. In oxygen, we have 2 moles of oxygen containing these particles. But inside oxygen itself, we have O. This O has 4 particles in them. That's what they are saying. 1 mole of oxygen contains 2 moles of oxygen atom. Try to follow this, because from here we shall never come back to this thing again. This one, we shall never come back to this again. We are going to continue deep down in the mole concept. So here they are saying 1 mole of oxygen contains this. What about 4 moles of the oxygen atom? It has this number of what? Atoms inside. So when it comes to ions, that's where I'm going. I want to show you how these ions come about. In sulfuric acid, how many ions are there? Sulfuric acid. How many ions are in sulfuric acid? When sulfuric acid dissociates, or when you separate sulfuric acid in water, when acid dissolves in water, what are the ions that are present? Yes? We looked at acids and bases with senior tools. That is, I wanted, some of you were there last year on Saturday. So they said when sulfuric acid dissociates in water, that means it turns into aqueous. Sulfuric acid into aqueous state. We shall form this. How many hydrogen ions are there? There are 2. But hydrogen is a first valence 1. So this is aqueous. Plus, the what remaining with the sulfate ion, which is SO4, it has a valence of -2. Since it is only 1, we just write it like that, aqueous. So sulfuric acid turns into ions when it goes to water to form this hydrogen ions and the sulfate ion. We defined acids as an element that when dissolved in water produces hydrogen as the only positively charged ion. As the only positively charged ion. These ions are others, but the main one is this. So since there are 2 here, we write 2 hydrogen ions plus sulfate ions. So you must know these ions from the start to the end. These are radicals. You don't need to separate them, that sulfate alone, oxygen alone. It's a radical. The way it is written is like that. It is here in the book, in our paper here. You say sulfate ion, it is here. Sulfate ion. So if you write a sulfate ion in a funny way, you will fail. So this is a sulfate ion, this is a carbonate ion. Learn how to write these ions as early as this, so that you don't tell people that you wasted money attending these online lessons. So here, this is what happens. Now the question is, the number of hydrogen ions in 2 moles of sulfuric acid. The number of hydrogen ion particles. They want the number of hydrogen ion particles in 2 moles of sulfuric acid. Now, you cannot get these ions if you don't know how this equation comes about. That in sulfuric acid, 1 mole of sulfuric acid, there are 2 hydrogen ions. You will start getting, where did people get 4 from? This is 4 here. You say in 1 mole, you are not seeing, in 1 mole of sulfuric acid, we have what? 2 hydrogen ions. 2 hydrogen ions. They are here. But the question is the number of hydrogen ions here. The number of particles of hydrogen ions in 2 moles of sulfuric acid. If you say these are 2, meaning these ones are going to be 4, these ones are going to be 2, because this one was for 1. What if there are 2 moles of sulfuric acid? 2 moles of sulfuric acid contain 2 times 2, which is 4 hydrogen ions. 4 hydrogen ions. Then now you say 1 produce this. You know the number of particles present in 1 mole of what? Of a substance. In 1 mole we have 6.02 times 10 to the power 23 particles. What about 4? It will become 4 times 6.02 times 10 to the power 23. So when you multiply the answer and get, you will come to this one, 24.08 times 10 to the power 23 atoms, or 2.408 times 10 to the power 24 atoms. So here, that's what we have. The question is basically on hydrogen ions. So we don't mind about the sulfate ions in the solution. That's a good thing with molar concept. They give you where the question is based on. So they want the number of hydrogen ion particles in 2 moles of sulfuric acid. So you first know that sulfuric acid produces how many ions? There are 2 hydrogen ions. So even if you leave the other sulfate, it has no cost. Now you ask yourself, if this is 1 mole producing 2 hydrogen ions, what about 2 moles of sulfuric acid? What about 2 moles of sulfuric acid? 2 moles of sulfuric acid will give us 2 times 2, which is 4 hydrogen ions. So if you want particles, 1 mole of sulfuric acid contains 6.02 particles. What about 2 moles? Actually, you go back now and lay your whatever on hydrogens now. On hydrogens, say 1 mole of hydrogen ion contains these particles. What about 2 moles of sulfuric acid? 4 hydrogen ions, which is 4 times the hydrogen ions. Then you get 4 times the particles there. This is the answer. It stops there. Okay? Now, there is that I've highlighted. Are we there? Cynthia? Cynthia?
Yes, teacher.
Let's try to unmute and we talk. Any problem so far? No. Maya?
Yes.
Yes.
I'm still trying to understand the 4 ions of oxygen, the ones we're talking about.
The 4 ions here.
The 4 ions.
The 4 hydrogen ions here. Now let me rewrite this statement here. We said sulfuric acid is SO4, isn't it?
Yes.
Now, if you dissociate, if sulfuric acid dissolves in water, okay, it becomes aqueous. Now, if it goes into water, it will not be sulfuric acid. It will be in terms of ions. We shall have hydrogen ions. Since hydrogen has power, one, here we see 2 hydrogen ions. You get? So we can't write these
Yes.
2 here. We put it behind. 2 hydrogen ions. Plus, this one is in aqueous state. Now, this one is in water. In water, we shall see 2 hydrogen ions and a sulfate ion, which is 2,4. This one will also be aqueous. That is what we have in sulfuric acid. But our question is the number of hydrogen ions, the number of particles of hydrogen ions in 2 moles. This is 1 mole. This one here is what? 1 mole. What about if there are 2 moles of sulfuric acid? If there are 2 moles of sulfuric acid, what will it give us? It will be 2 times the rest here. We multiply this by what? By 2, which we shall produce 4 hydrogen ions, aqueous, plus 2SO4, 2 minus aqueous. So here, the equation is basically based on the hydrogen ions. So we say 1 mole of sulfuric acid, 1 mole of sulfuric acid produces 2 moles of hydrogen ions, isn't it? Now, what about 2 moles
Yes.
of sulfuric acid? What does it produce? It produces 2 times 2 moles of what? Hydrogen ions. So here we shall have how many? 4 hydrogen ions. Good. So now if it comes to particle, 1 mole, when you go back to the definition here of our particles or mole concept, we get to know that here, 1 mole of a substance has this number of particles. Those particles can be grouped into molecules, atoms, ions are here. Have you seen ions? So it is the same. 1 mole of hydrogen ion produces or contains 6.02 times 10 power 23 what? Particles. So here, 1 mole of the hydrogen ions contains 6.02 particles. But in 2 moles of sulfuric acid, we have how many ions? 4. What about 4 moles of hydrogen ion? It contains what? Contains 6.02
14.
times 10 power negative power 23 times 4. These are particles. So if you multiply this, it comes to 24.08 times 10 to the power 23 particles. Any other question? Please.
Yes.
Any question?
Yes, teacher.
Yes, yes.
No, there is no question.
Patricia. 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 Yes. So are we now contented with this work?
Shall first wait.
Yes, yes, I'm waiting.
Shall like if that to ask you to find the number of hydrogen, I mean to find the number of ions in oxygen, I supposed to multiply 2 times the number of oxygen ions in this substance here.
Which one? In this substance. Now here.
Shall like yeah, like this SO4.
SO4.
Okay, shall like if this SO4, like if they are to ask you to find the number of oxygen, okay, oxygen ions or something of that kind, like are you going to multiply 2 times the number of this or what? Like if they are to ask you to find it in 2 moles.
of this iron. The number, now they will change it.
Yeah.
They will not ask for one particular substance here. They will not ask for one because this one is considered a radical. It is one. They can never ask for one of them unless this one also further undergoes dissociation to form some other thing. But in chemistry, I've never heard of that. But they might ask you the number produced by 2 moles of sulfur, maybe the number of sulfate ion produced by 2 moles of sulfuric acid. You get it? But they can never ask for only one atom in a sulfate ion. It is not easy to remove this O4 from this.
Yes.
Okay. For now, this one is going to be our exercise. If you take a snapshot of this thing here, we shall do only this part. These 4 questions. Then I'm going to send this work. Since we have downloaded it, you can do for me exercise 1. Is it okay? Yes? Is it fine?
Yes.
Yes.
Okay. You do for me A, B, C, D of number 1, A up to D. Number 2, we shall start from there next time. Thank you for attending.
Excuse me, teacher.
Yes?
How are we going to submit the work?
On WhatsApp, I'm going to send you a WhatsApp number. Is it okay?
Okay.
I'm going to send you my WhatsApp number.
Yes.
Okay. Thank you for attending.
Okay.
Wish you the best.
Thanks, teacher.
Welcome.